So, what are we going to talk about today? Hydraulics engineering. Yeah, so my new title is a state hydraulics engineer as soon as they put the state geotech engineer in place. That's going to be fun. I'm not going to read this to you, but hydraulics engineering is hydrology and hydraulics, culvert, stormwater, and stream engineering. So if someone walks in and says, oh, I'd like to talk to a hydrologist. Sorry, we don't have any hydrologists. That's the Department of Water Resources. Those are the people who figure out how much water there is. We're actually an engineering wing that does hydraulics engineering that uses hydrology. Program services, similar to the geotech, where we have the expertise in headquarters, but you also have the expertise within the region tech centers. We write the standard scopes of work. We provide a lot of support to maintenance when there are flooding issues or permit application issues for developers, in-house training, and bringing in professionals from universities and national experts to train our staff. The standard drawings, asset management, specifically in the area of culverts and stormwater. And we also, the statewide transportation improvement program funding management. What does that mean? That means that we also oversee a large pot of money. If you've ever heard of like the bridge program, they fund the bridges. The pavement program funds the pavement work. We administer the oversight of the funds for culvert replacement and repairs across the state. Technical support, it's bridge hydraulics, it's culverts, it's getting the water off the surface of the bridges, culvert repair technologies. We can't afford to replace every culvert in the state as they wear out, so we're employing liners and grout applications and stuff to repair culverts. Fish passage design. It's not what I learned in college as a civil engineering student was make the culverts as small as possible and put great big piles of dirt on top of them and get the water through it as fast as you can. Unfortunately, fish don't like swimming up fire hoses. So we are much more environmentally sensitive now and do a lot of design to make sure that the salmonids can get up the streams and we can have more fishes in the future. Large channel designs, stream bank stabilization, sometimes that's related to landslide mitigation as well. Stream restoration, which is a more environmentally sensitive type of design. Complex energy dissipators. At the ends of pipes, you have big scour holes. We want to control that. Floodplain hydraulics and documentation, that includes like FEMA applications and small pump stations. Typically, if we get into large pump stations, we'll outsource that type of work, because that's a specialty area that also often requires mechanical engineering and electrical engineering and control systems, not just the hydraulics aspect. Control structures, tide gates, weirs, temporary water management. That's a hydraulic aspect that supports construction. So if you need to temporarily get the water around a construction site and keep it dry, we design those. Structural scour and erosion protection designs for like around bridge foundations. Stormwater quality designs. We actually have a MS4 permit with the Department of Environmental Quality that requires us to manage our stormwater in a certain way, and we also have regulations with National Marine Fisheries and Department of Environmental Quality, and that requires us to do stormwater treatment before we let the effluent enter into the waterways. Stormwater control facilities, which would be like a detention pond or a retention pond, so that's to alleviate flooding. And sometimes the water quality and the flooding can be designed together. So then it gets more complex, but more efficient for the transportation system. Roadway drainage, that's getting the water off of the road. So when you're driving down the road and you're hitting a hydroplaning area, hydraulics engineering is covered in the hydraulics manual on how to appropriately put the cross slopes on the roads and super elevations in relation to getting the water off. So even though you don't always need a hydraulic engineer to do that work, we actually provide the training on how to do that work, and lots of times a roadway designer can actually do the roadway drainage work. Storm drain systems, that's the pipes underneath the road. So you have inlets in the middle in the streets, and it goes down to a pipe. You're sizing the pipes. Siphons, those are more on the, in support of irrigation systems on like the east side of Oregon, where you have irrigation districts, and you'll see these canals. It doesn't look like it's flowing, but it actually is. It's just really, really flat out there. It comes up to a road, and then suddenly it looks like the water just goes nowhere, and it shows up on the other side of the road, where there's actually a pipe underneath the road. That's called a siphon. So you design those. And then drainage markers, identification, those are essentially little signs that we put out on the road so we know where the culverts are. So here's some fun pictures of some stormwater management best management practices. You have a detention vault up on top. Some of them are prettier than others, let's be honest. You have some storm sewer installations over in the upper right. That's, you got some shoring in place so you can install the manholes in the pipes. And it's safe for the worker to be down there. Many times you have to do joint work as well to connect each piece of pipe. And then stormwater detention ponds. Sometimes it looks like they're not, if you think they're full of water, you might think, oh, it's failed. It's like, no, it's actually supposed to be doing that. So those are holding back the water so it doesn't flood downstream. Then we have some, what we call more like a lower impact development type of stormwater management systems. These are like underneath the gravel. It's a bioslope where the water goes off the edge of the road and down through some media that we put in there and into the soils and produces infiltration. Bridge hydraulics. So, you know, the bridge engineers are really important because they design the structural part that goes over the river. What the hydraulic engineers do is they design that hole underneath the bridge. So we work very closely with bridge designers to determine how high it needs to be to make sure that we don't cause flooding upstream or cause erosion, have the river cause erosion. Then here's some fish passage examples. This used to be like a much smaller culvert, like a 4-foot culvert, and this is now a 12-foot diameter culvert, which has been placed down into the original ground a little bit, and then we put baffles on the sides, and you can see down the bottom right that there are fish that came right up that culvert. That was like 2 days after that had been opened up to the natural waterway. Then we have some unique types of installation. This is actually an inverted box culvert. They put down in the ground, then put natural stream bed on the bottom, and then put a slab on top of it, so then you didn't have to go in there with equipment to install that. So essentially you now have a culvert with a natural bottom all the way across. Culvert pipe replacement. This is a very large pipe. I believe this is on Eddyville. Remember the picture of the bridges, that columns that they were exploding and hauling away on the truck? They decided to put this pipe in place and then put a bunch of dirt on top of that. So it's another way to convey water. Pipes often are more flexible, and dirt is more flexible than if you put like a rigid type of solution in. So this is a large enough pipe that you can drive through, but it's intended for fish and other types of habitat, and a little bit of water. Stream bank stabilization. So again, this is a case where you have the river eating away at the side of the road, and so we'll go in there and design a type of mitigation to keep that from taking the road away. And then you have different types of slope repair. Sometimes it's rock, sometimes it's willows with rock down at the bottom. You can put in concrete blocks, all types of things you can do to protect the roadway. Stream bank, some additional stream bank stabilization here. This is an actually completed project. It's over in eastern Oregon. You can see there's a whole bunch of rock along the sides. So you might say, oh, they're just putting rock in there. Well, actually, there's an engineering process to size the appropriate size of rock, depending on the velocity and the energy of the water in the waterway. If you just put rock in and you haven't done that engineering, typically you don't put it in large enough rock and it just washes away. Stream restoration, you can see in the before picture where it's just bare dirt and soil and rock, where on the right there's some vegetation that's really important to meet environmental compliance. And the bottom left-hand corner is even a better example where you have woody debris and sinuous channels, which is what is more natural than the upper right scenario. In the bottom right, you can see where the stream bank work was more than just rock. It's a combination of rock and wood and twigs and plantings. This is some of the more exciting stuff that we tried not to have happen, but when you had the big floods in Oregon occurred in 1964, 1995 were the two biggest ones. I was actually here for both of them. Not all of you were. So you were looking at, it's interesting because we do design our roads to not be flooded, for the appropriate return period storm. If people talk about a 100-year storm, what does that really mean? That means it has a 1% chance of occurring any given year. That doesn't mean it only happens once every 100 years. It's a probability. So we're looking at roadway overtopping. You're also looking at how it affects the bridges. You see how it doesn't just overtop the road and go away. Often it washes the road away while you're at it. Here are some examples of erosion underneath the road after a flooding event. What happens is it eats around the end of the culverts. You have debris that catches, and then you have to remove those, and you need design for that. Lots of times we're out there with the maintenance folks to help them figure out how to safely remove the material. And then the bottom right, you see effects of corrosion. This is where we're looking at the bottom of a culvert is essentially gone. The only reason it's still staying there is the arching effect of the soils over top of the pipe. And so we go in there with culvert repair technologies, and sometimes it's structural, sometimes it's not, and try to fix those repairs and repair those culverts. So here is an org chart of your region resources. We have a senior hydraulic engineer in 1, 2, 3, and 4. Region 5 has a hydraulic engineer. He's a journeyman level engineer, and we're mentoring him on how to do this work right now. And so going to your region hydraulic engineers is a really good resource, and they know that if they can't answer the question, that they will come to headquarters where we have several senior people as well. I'm a state hydraulic engineer, but we have Robert Travis, Wade Holliday, and Lou Seichow, who I think is somewhere in the room, who helped me put this presentation together. Thank you very much, Lou. So we have lots of manuals. You saw the big blue ones that we have. They reference a lot of Federal Highways manuals. We have AASHTO guidance. We have an entire suite of hydraulic software, which we do watch very carefully on who gets that software to make sure you're appropriately trained on how to use it. We have a design deviation request, just like the geotech design manual does. And the approval process is the same, where you go through your region senior hydraulic engineer first for preliminary approval, then it comes to headquarters for final approval, and then for either my signature or the state bridge engineer for final approval, depending on whether it's a bridge hydraulics issue or any other hydraulic issue. Quality control is very important. We want to make sure our very expensive designs don't wash away. And we're developing a similar process that Stu talked about for the geotech program. Here's an example of our DAP deliverables. Coordination is important, especially with survey, environmental, bridge, and roadway. Survey is really unique for hydraulics because we actually need surveys underneath the water of a river. So it's not something you can just do from the aerial. And we provide our services primarily to environmental, bridge, and roadway. Success depends on communication. Hydraulics is an iterative process. You start with an area, you do a calculation, you come all the way back around, you decide that you see if it worked or not, and then you have to move your area. So it's like it goes around multiple times till finally you come up with the right design. So in summary, we do drainage facilities with culverts, inlets, storm drains, stormwater BMPs, channel designs, hydraulic structures, culverts, head walls, fish passage, repair technologies, big bridge hydraulics and scours, stream banks, floodplain studies. And I'd like to point out one thing. If you ever hear any questions about in relation to drainage law, there is no such thing. There are no laws on the books in the state of Oregon talks about drainage law. It's all based on case history. So where do you get your resource, your questions answered? Go to your hydraulics engineer. If they don't know, if your regional hydraulics engineer doesn't know the answer, they'll come to headquarters. We have a lot of experience dealing with Department of Justice and lots of different legal situations we've had to deal with. So it's really just based on case history and experience. Thank you. Questions? Oh, no lunch yet.
I'm going to walk over here.
Stu, why don't you come on up? Then I have a question for you too.
Hey, I got a hydraulic question. I'm from out of state, and one of the big things in the hydraulics for floodplain is getting your CFPM, the Certified Floodplain Manager. Is that something Oregon does, and would you suggest that we should pursue that if that's kind of where we're
That would be the question is related to the floodplain manager, and every area of the state of Oregon is a little bit different on who that is. ODOT is not the floodplain manager. It's usually going to be your county or the city. Your hydraulic engineer will know that. So,
well, less as an individual person, more of this being a certified. I think California does it. Texas does,
no, that's not a requirement. It's not a requirement in Oregon to be a certified floodplain manager. Again, if there was that requirement, that would be the responsibility of the cities and counties. It wouldn't be ODOT itself. Yeah.
Thank you.
Can you speak to ODOT's process for identifying culverts for upgrading or replacement due to fish passage issues?
Sure. So fish passage, there's many layers to this answer, so hopefully I have time for it. But ODOT actually entered into an agreement along with the governor's office as part of the salmon recovery plan years ago. And so we actually have made a commitment, and we put a large amount of money, I think it's between $4 and $6 million per year, into a fund, into the culvert program just for removing fish barriers. So that is independent of the legal requirement of the fish passage laws that are in the books that requires all of our normal projects that actually like do a widening, a significant project, actually has to bring all hydraulic structures up to current fish passage standards. So you have your regular project has to do fish passage. We have a pot of money that goes out and identifies the highest need, the best value to remove barriers. And we actually work very closely with the Department of Fish and Wildlife on determining what those are. The Department of Fish and Wildlife has a priority list, high, medium, and low priorities, not just ODOT's, but of all crossing across the state. And we have made a commitment to pick those off from the top, working down or as best we can within our budget constraints. And we've actually done really well making progress on that. And if you're familiar with some of the lawsuits that have gone on up in the state of Washington, WashDOT is now being required to do all this fish passage work. ODOT hasn't been sued because we've been proactive and we're actually doing it on our own. So we've made some really good inroads with the Department of Fish and Wildlife and the National Marine Fisheries. And so actually now, we actually have a fish passage coordinator, and that's one of his primary duties is to work with ODF&W and come up with what our program is going to be and how we're going to spend those dollars and get the most habitat improvement as we can.
We have time for one short question. Does anyone have one of those? Okay, gentlemen, thank you very much.